Good evening and welcome to the first of the Enterprise Forum dinner programs of the year. My name is Jimmy Gia and I am the chair of the MIT Enterprise Forum of the Northwest. We are pleased to be kicking off the season with a special program held jointly with the Economic Development Council of Seattle and King County. This is the first in over a dozen programs designed to inspire our leaders and ideas that'll shape our future. We are an all-volunteer nonprofit organization, part of a network of 28 worldwide chapters. We are managed by Technology Review, an independent media company owned by MIT with a global readership of over 4 million. Let me take a quick poll. How many of you are coming to your first MIT Enterprise Forum of the Northwest event tonight? Wow. Well, welcome and thank you for coming to attend. We hope to see you again at one of our future events, and you can see a couple of them in our handout in the programs. On October 3rd, we're going to be talking about the dangers and the opportunities of the new SEC rules for funding. And on November 13th, the next dinner program event like this, where we're talking about big disruptions in the energy industries. Yeah, and you'll also find a flyer inside of the programs regarding a gold pass for a ticket for the rest of the dinner programs as well. And if you purchase in September, we'll credit your ticket cost for this event as towards that and also include a free subscription to the MIT Technology Review. So please feel free to act on that. If you enjoy tonight's event, you can also become a volunteer. And you can help inspire, connect, and educate tomorrow's leaders as well. And tonight's planning committee has done just that to assemble for us a fantastic program. And so please stand when your name is called. Nat Seymour, who is our team lead, Steve Gerritsen of the Economic Development Council, Vicki Owens, Doug Gellert, Nicole Pasternak, Jamie Wiegand, Manu Hoya Barkham, Renee Gastineau, Bhavali Lal, and Donna Hines. Will you please stand up and get some applause? And none of our events would be possible without our sponsors either. And so please give a round of applause for Talaferro IT Consulting, Frommer Lawrence & Haug LLP, Equinix, Point B, and Summit Law Group. Thank you very much. And so without further ado, please join me in welcoming our events moderator tonight, Doug King, President and CEO of the Museum of Flight, whose job tonight will be to stretch our boundaries of imaginations. So thank you very much.
Well, thank you very much, Jimmy. And thank you to the Enterprise Forum and all the committee members that were just introduced for bringing this great event here, bringing us all together. The title is perfect, Space, Are We There Yet? I think you can find opinions of every sort out in the public. We did a survey here at the museum not long ago asking people about what they think of the future of space. The answer was fascinating. People have no difficulty with a Star Trek version of the future. They just have a really hard time with how we're going to get there. I had a high school principal say to me the other day, "Why would you talk to kids about space? They'll never be able to go." And I said, we have a little work to do. So I hope by the end of the evening, you're all going to be advocates and you're going to listen to some of the people that are really making change happen. We hope this can be a great discussion. What we plan to do is to introduce each of the panelists and let them sort of give their background and their view on the topic of the evening. Then we'll have a discussion between them, and then we will invite your questions and comments and discussion for the last part of the program. First of all, let me do a couple of logistical things. We are in front, as you certainly can tell, of the full fuselage trainer, the shuttle trainer from Houston in Building 9. Those of you that know the space industry know that every astronaut that went to space trained on this vehicle. They did mission simulations, they did egress training, they did payload integration training in the payload. And so if you haven't been up inside, we invite you into the payload bay. I know a lot of you got to go into the crew compartment beforehand. We can't do that afterwards tonight. But anytime you'd like to come back to the museum, it is the only place in the country where you can go inside the crew compartment. I keep telling people, go see the orbiters in Los Angeles and Kennedy Space Center and the Smithsonian and stand back and don't touch and then come here and go inside. And we think that's important because what we want to get across to people is this incredible workhorse of the last 30 years that paved the way to live and work in space that we think is so realistic to come, and help young people understand both the challenges and the excitement that that the bloom has been off of for the last few years? How can we reignite that spirit and that interest to inspire more people to help us all make that journey? Logistically, there are restrooms directly behind me here. We invite you not to use the mock-up of the crew compartment restroom over here, or the one of the Soyuz. When we dedicated this room, Charles Simoni, the room is named after him, who was so generous in helping to build it and to donate his Soyuz capsule, brought out a video and said, I'm going to show you what we did on orbit to demonstrate the use of the toilet facilities. And we all cringed a little bit, but they did use a squirt bottle. And so it passed muster and was the most popular thing in the opening ceremony. So we put it on display. It's the #1 question everybody has to ask. And we hope that one that we'll all be able to answer eventually with the help of the people on the stage. It's an extraordinary panel, a great audience. Let's have a great discussion. So let me set the scene a little bit. Here at the Museum of Flight, our mission is to tell the story of the first 100 years of flight and how it changed the world, and to help inspire the young people that will continue to write the story on into the future. And there's some very interesting things we've discovered over the last several years as we looked at how do we integrate the space story with that of aviation. You know, it really isn't trite to say that for thousands of years, people looked up in the sky and dreamed of going there, whether it be the stars or a distant cliff or watching the birds soar above a beach. It was literally only an eye blink of history ago that people first achieved that dream. 1903, you know, a 320-foot flight that lasted 17 seconds. And suddenly, the idea of flight wasn't a dream anymore. How quickly, I mean, how short is 100 years and how much has the world changed because of that? I mean, think about today, the expectation that you can get on a plane, 20,000 domestic flights within the United States every day. We expect them all to get where they're going, pretty much on time. And that we can pretty much decide today where I want to be tomorrow, anywhere in the world, and be there. It's changed where we live, where our families are, who we do business with, how we do education, how we communicate with other countries, how we buy things, how we communicate on our cell phones. That 100 years has just completely changed the perception of how big the world is. And some of it happened pretty darn fast. You know, it was only about 50 years after that first flight that travel in an airplane was pretty common. After the war, by the 1950s, most people could afford to take an airplane flight, and it certainly became ubiquitous in the 10, 15, 20 years after that. So here we are now 50 years after the dawn of space, after Yuri Gagarin and Apollo and so on. And we're on the verge of a major change in that arena too. I think the best analogy that I can see from my career, I'm older than most of you, and I worked in Silicon Valley in the late 1970s, and I can remember very literally when people would say to folks that worked at Hewlett-Packard or IBM or Intel, what do you think of this personal computer idea? And the answer was almost universally, what would you do with one? What would you do if you had a computer at home? You know, you'd keep your recipes on it. You might write, but you've got a typewriter already. And so the idea that how much the world has changed since the late 1970s is just dramatic. You can't imagine the difference in perception. And of course, it wasn't the people who were working at IBM and Intel and Hewlett-Packard that changed the world. It was people that were entrepreneurs, out doing something a little different, out maybe even stealing some parts from Hewlett-Packard to build the Apple I, and saying, we're going to do things differently, and of course they have. And it's funny to look back and think of someone like Steve Jobs as an icon, as a visionary. And when I met him, he was a scraggly, bearded kid that nobody took seriously. And so I'm not going to draw an analogy between Steve and anybody on the stage today, but I think the visionary part of it definitely fits. People are out there betting their careers, their companies, their money on the idea that we will go to space. If that analogy is not good enough for you, if that idea that this really is an inflection point, I have another one that my nephew, who's a freshman in college, gave to me the other day. We were sitting talking about how he's a sophomore this year, how much he enjoyed his freshman year. He said the most interesting thing I did all year long was a professor gave us an assignment to get together in a study group and talk about What will historians 1,000 years from now write about our times? Now, you can do this, I've discovered, at a cocktail party or at a group at work or in 2 minutes if you want, but it's really an interesting exercise to say to people, how much do you know about the year 1013? You know, we have a vague understanding, most of us, of European history and very little understanding at all of the rest of world history, but basically we don't know much about what happened 1,000 years ago. So what will people in the year 3013 write about us? Get a group of people together around the dinner table or at work and discuss this for a while, and what will happen is pretty quickly you'll realize it probably won't be who won the presidential election or what's going on in Syria this week or who won the football game last night, the things that we spend most of our time thinking about. People, if they give it some thought, will come up with some pretty interesting ideas. Maybe this will be the era that's remembered for discovering atomic power and whether we survived that or not. It will probably be remembered to be the era where we began to understand how humans interact with the climate, energy, healthcare. So one person postulated the great achievement of this era is feeding 7 billion people on the planet, the population explosion and the agricultural revolution. Well, those are all really interesting ideas and you can have a great discussion about them. But the one answer that you will always find in any group of people is that 1,000 years from now, people will write that this was the era when humans first left the Earth. First into the atmosphere and then beyond. And that's what we're talking about tonight. So we may get into a debate or discussion later about whether it's going to be this year or next year or 5 years from now or 10 years from now. 1,000 years from now, people aren't going to care. They're going to say this was the era when humans first left the planet. What an amazing moment to be alive. The work that's being done already in interplanetary exploration, the fact that the first human object left the solar system, announced last week, left the solar system last summer, and that we're learning so much about our neighbors. This will probably be the generation that discovers whether there's life in our solar system or not. Maybe not the rest of the universe yet, but certainly we're going to explore all the planets in our solar system. And so the idea that something important is happening, if you find a doubter, challenge them. What will historians write 1,000 years from now about our time? That's what our panel is here to talk about tonight. So I'm going to introduce each one of them very briefly, let them tell you a little bit about themselves and their view on this topic in general. And then, as I said, we'll have a conversation between them and then a conversation with you. So let's get started at that. Our first panelist is Will Pomerantz. Will's Vice President for Special Projects at Virgin Galactic. I think all you know that they're the ones we're expecting to take us first. Now, Will, I can't afford a ticket yet, but I'm working on it. So I want you to tell me when I'm going to be able to go and how this whole thing's going to evolve. Ladies and gentlemen, Will Pomerantz.
My name's Will Pomerantz. I have the great pleasure of working for Sir Richard Branson at Virgin Galactic. I'm a lifelong space nut. I grew up like most little kids, wanted to go to space. I just never grew out of it. I made that my pursuit in college and ever since. I spent my time working at NASA shortly after graduation. Got to meet some wonderful people there, like Chris, inadvertently through that. But I came to a realization over my early years of working. It's the PDF file up towards the left. There you go. For NASA, that as much as I love and admire that organization, it's not NASA's job to take me to space. That's not what we ask NASA to do. That's certainly not what we fund NASA to do. As much as I want to go, and I'm willing to bet, since you took the time to come out to this event, probably most of you want to go, that's not what we ask NASA to do. It's not what any other country has asked their space agency to do. There we go, perfect. And let's see, will this work from here? All right, perfect. There's sort of no historical precedent for it. I wanted to start with this number here. This is a number that's at the forefront of my brain every day when I first wake up, and certainly when I first go into the office. 541, that is the number of human beings who have ever been to outer space. from the formation of the planet, the birth of the human species, until today. 541 people, starting with Yuri Gagarin. We just added a few to this number a month or two ago. And I have two simultaneous thoughts about that in my head. One is how wonderful it is that I live in this era when that number is not zero, like it was throughout all of human history. You know, there were something on the order of 100 billion people who lived and had that number be zero throughout all of their lifetime. But on the other hand, if you had asked me when I was a child growing up what that number was going to be in the year 2013, the answer I would have given you would have been a heck of a lot larger than 541. I grew up watching The Jetsons, I grew up watching Star Wars, I grew up watching 2001: A Space Odyssey. I assumed by 2013, we're a dozen years after 2001: A Space Odyssey, surely I'll be able to just buy that ticket on the Pan Am shuttle to the station orbiting the moon. Surely I'll be able to commute via work. I'll be able to take vacations during work, vacations to space. I'll be able to do work in space. I'll be able to go there for fun. And that hasn't happened. Not necessarily because we're not smart enough to make it happen. We have sent people to space. We brought them home safely. It's a wonderful thing. But because, as I was saying, that's not what we have historically asked our space agencies to do. So if we're going to increase that number, not in units of 6 and 7, as space agencies usually do in a year, but in units of hundreds or thousands or hundreds of thousands, like I would like to increase it, it became clear to me that we're going to need the involvement of private companies. We're going to need somewhere where I can go and buy a ticket to fly to space the same way I flew from Los Angeles to Seattle this morning on Virgin America, the best airline out there, I'm contractually obligated to say, and happen to actually believe. So that was kind of my idea as I entered the industry, but there's a difference between thinking that's what should be and thinking that's what can be. So a really big moment in my life and my career was when this vehicle was built and first flew. There's actually a pair of two different vehicles. You have carried underneath the mothership there, which is called the White Knight, you have a vehicle called Spaceship One. This is the first ever privately built vehicle to carry human beings to outer space. It flew to space successfully 3 times in the summer and the fall of 2004 in order to win something called the Ansari X Prize, something that Doug certainly can tell you a lot about and played a significant role in. And this was exciting to me, not only because it looked cool and the people behind it were cool, people like Burt Rutan, some guy named Paul Allen you may be familiar with, but also because I knew that vehicle was built for about $25 million. And it was built in such a way that the cost of the second flight and the third flight was just about zero. If you look at any space vehicle that's ever been built, Russian, American, Chinese, humans on top or not, the cost of sending things to space is all involved in human labor. We don't yet power our rockets on dilithium crystals. Rocket fuel is cheap. The parts are cheap. The people are expensive. So this vehicle built very quickly in just about 150 person years. The time required to prepare for the second flight was measured in person days. It meant that the cost of that second flight was almost nothing, which meant that I might be able to buy a flight on the second or the third option, which was very exciting to me. So this was designed by a company called Scaled Composites, funded by Paul Allen. My boss, Sir Richard Branson, came in and commercialized this technology. We licensed it from Paul and his team, and we said we want to bring that vehicle, which was really a test pilot's vehicle, we want to bring it to market and make it so all of you can fly missions. I'm not going to go into great detail about this, but this is our flight profile. We're a suborbital vehicle, so we don't go into full orbit, but you are genuinely in outer space. You get to experience about 4 minutes of weightlessness, float around a large spacious cabin, and you earn your astronaut wings, hopefully for many of you fulfilling a lifelong childhood dream. This is the facility we'll fly from. It's called Spaceport America. It's the world's first purpose-built commercial spaceport. It's really a beautiful place. It's where, if you buy a ticket, hopefully when you buy a ticket, you will come and do your training. We have about 3 days of preparation before you fly. We've tried to design this system so just about anyone can fly, regardless of your current state of health. If you've had the pleasure of meeting a NASA astronaut, you'll know that most of them are in peak physical condition. Some of us who are not in peak physical condition, like myself, would like to fly as well, and I'm not necessarily in marathon shape. I can certainly fly on this vehicle. We have passengers who are in their 90s who have been medically cleared to fly on this vehicle. Actually, if we could maybe switch over and roll to the video, I want to show you a test flight that happened about a week and a half ago. So we're now in the later stages of testing of Spaceship Two, our commercial suborbital vehicle. We became, earlier this year, the first commercially built, commercial service-intended vehicle to break the speed of the sound since the Concorde first did it back in the early 1970s. So this will roll here in a second. This is our second rocket-powered test. We're getting towards the end of our test flight program. We are now going faster than the speed of sound. We're taking all the critical parts of our suborbital spacecraft and we're testing them in sequence. So here you go. You got the spaceship in the center, the two fuselages of the mothership above, and now we're releasing, and there goes the rocket motor. And this is the fun part. You'll be carried up to about Mach 4 on a full space flight. On a full space flight, that rocket motor will fire for somewhere on the order of just over a minute. On this test flight, it lasted for about 20 seconds. And that's going to give you enough total impulse to get up into outer space here. This was a really fun day for us on the ground, a great day for our pilots. They came down with grins ear to ear, as you can imagine. And it tells me that we're getting really close. Our goal is to be in outer space at the end of this year, not yet with commercial paying passengers on board, but we're going to get to that place really quickly. As of today, we've got somewhere on the order of 620 people who have signed up, who have paid for their tickets. It's $250,000 per person to fly, which I know is not the cheapest thing in the world, but it's a lot cheaper than the next cheapest alternative, which is about $65 million to fly with the Russians. So it's a pretty good deal, and it's a pretty good ride, and I get really excited that we have now more people who have paid up and are waiting for their flight on this vehicle than have ever been to space. So I think with that, perhaps in the interest of time, I'll go ahead and close. So I'm looking forward to the discussion afterwards. Thanks.
Our next speaker is looking a little farther into the future. Chris Lewicki is the president and chief asteroid miner for Planetary Resources. I've never seen a phenomenon like I saw when Chris and Eric Anderson and Peter Diamandis were here to announce the launch of the company last April of 2012. The outpouring from around the country was just incredible. And the number of people who wanted to essentially bet their career that we will go mine asteroids. You may have seen this summer the Kickstarter campaign that they did to help fund an educational project that we will do together to follow their progress as they build the first Arctic telescope, launch it about 2 years from now, and then use it for educational purposes. You know, we're about 100 yards from the new Raisbeck Aviation High School that opened here at the museum last week, and Chris has had 6 students each of the last 2 summers as interns at Planetary Resources. It's pretty fascinating to talk to these high school kids about how they worked with people who launched the Mars rovers and are now thinking of mining asteroids. But the kids can't tell us too much because they all have to sign a non-disclosure agreement. So Chris, tell us what you can about Planetary Resources.
Good evening, everyone. Very happy to be here tonight and at one of my favorite places in the world to speak. It is conveniently located to Planetary Resources headquarters and has been the site of a lot of exciting events for the company and really for the city of Seattle as we've been doing things. And I also want to thank the MIT Enterprise Forum for putting this together and having us all together. My history didn't start with asteroid mining, but my interest in space started with that spacecraft that was just announced to leave the solar system last summer. Voyager was something that inspired me to take up the cause of engineering, and in particular aerospace engineering, and pursue that to do the same thing that Voyager did, to explore our solar system, to look where humans can't yet go, but maybe will do someday. And I had followed that through 2 degrees in aerospace engineering and then arrived at the Jet Propulsion Laboratory in Southern California. And very earlier in my career had the awesome pleasure to kind of do the very thing that inspired me to get into the business, which was to build twin spacecraft to land on the surface of Mars and to inspire another generation to continue the cause. So I was involved as a system engineer and ultimately was flight director for the landing of both Spirit and Opportunity before I was 30 years old. And if that wasn't fun enough, I got to do it a third time when we landed the Mars Phoenix lander on the surface of Mars a little bit more than 5 years ago. So I've had a career in robotic exploration and really have worked with the best people on the planet in doing that type of work. And when my co-founders, Peter Diamandis and Eric Anderson, approached me about going out and approaching and mining asteroids, it was something that I knew exactly how hard it was going to be, but nonetheless thought it was an important thing to undertake. So the mission and vision, and I'm going to give you just a very brief overview of asteroid mining and how Planetary Resources is pursuing it. Our mission at Planetary Resources is to expand the economic sphere of influence of our species. A very broad goal that does not mention asteroids. In doing that, we want to create new economic opportunities and also to diversify our resource base and turn what is one planet, one very fragile oasis that we have in the solar system and in the universe, into just the place that we got started. And as we explored this country and as Lewis and Clark expanded out into the West, it was through the development and use and mastery of resources that they were able to do that. The greatest opportunity for wealth creation really began when we started exploring the New World. And we didn't send in supply ship after supply ship after supply ship. We learned how to use the materials that we found in the places that we explored, and in doing that became self-sufficient. And if we needed to have ships supplying us every day here, we wouldn't have lasted very long. So our near-term focus in doing this is much like any other mining or resource interest. We've got to find out more about these resources in space in a way that allows us to develop them. We're standing on the shoulders of 50 years of exploration that was provided by NASA and other space agencies around the world. And without that, we would not be able to take the next steps, kind of what Doug was talking about with the personal computer. The government wouldn't have created a personal computer for consumer use, but the private sector saw the opportunity to adapt a government investment and pursue a business opportunity and create something truly pervasive off of something that was only available to a few elite institutions and government entities at the time. And this is something that we too look to do, much as Brute Rutan and Paul Allen did at Virgin Galactic, with a small team. Today's technology and our knowledge and our capacity as humans, as engineers, as scientists, and as businessmen allows us to do with a very small group of people what used to take the entire governments or huge companies. So this is really the fun part about what we're doing. We've got a fantastic team here in Bellevue. Eric Anderson is our co-founder and co-chairman. Eric was the gentleman who will sell you that $65 million trip to the space station, and people are still buying. Sarah Brightman will be headed up next, and Charles Simoni, who is the namesake of this space gallery, is the only person to have liked the trip so much, like he described when we were dedicating the building, that it's like Disneyland. You go back to the gate and buy another ticket, and they let you ride again. So Charles is one of our investors, and Eric, with him and a number of other pioneers, has helped build a certain part of the space industry. Peter Diamandis, the creator of an organization that really helped me hone my space interest, Students of Exploration and Development of Space, where I met Eric Anderson and met Will, and Peter went on to found things like the International Space University, the X Prize Foundation, and even an organization called the Singularity University. And with their vision of going out and creating really what's going to be the big thing in space in the next many years, and will be the thing that will remember getting us off the planet. So combining this with professionals like Mike Spelf, who have experience in actually building robotic spacecraft, other people who help build and land Curiosity on Mars, and even people who are building the chips that are in your computer. We're inventing a new kind of space company and pursuing how to take billion-dollar things that we know how to do very well and do them for an order of magnitude or 2 orders of magnitude cheaper so that we can commercialize that. We've drawn the interest of a lot of people in the process of doing this. Sir Richard Branson, Will's boss, was one person that joined us very recently. We've got pioneers from Google, Charles Simoni, as I mentioned, and even industry is actually taking interest in what we're doing. Bechtel Corporation is a global mining and engineering services company who sees that this is certainly the future of mining if there is a future beyond Earth. And also very innovative companies like 3D Systems, who are pioneering the frontiers of manufacturing. That's one thing that we're going to use those technologies, those exponential technologies, to help us explore space in a cheaper way. And when we get there, be able to stay there in a way that will be different than any type of manufacturing we've ever gone. Imagine being able to pull up to an asteroid, take the raw materials that you have there, the iron, the nickel, and the cobalt, put them into a machine and start printing out habitats. So this is certainly science fiction today, but you can actually see the roadmap coming together in a way that was once written about in science fiction. The foundations of this are now existing as businesses and industries that really just need to be put together to make it happen. So, very brief backstory, 50,000 asteroids have collided with Earth that we have in our laboratories. Many more actually have collided with that we know. And little things like carbonaceous chondrites that I have with me today and other ones you can come up afterwards and ask me about, allow us to really understand in detail what's out in the solar system, what it's made of, what the resources actually are. And we can combine that with astronomy and go out to space and really understand that not only do we have rare metals like the platinum group metals that are out there, the structural materials like iron, cobalt, and nickel that we can build future Starship Enterprises out of, but the things that we often overlook because we have this wonderful environment all here on Earth, the volatiles, hydrogen, carbon, nitrogen, and oxygen. These are the essence of life. We would not get very far without water. You can go a long time without eating, but you can't go very long without drinking. And water is a very expensive commodity to ship into space. But it just so happens we're discovering it everywhere in space. Not only have we found it on the poles of the moon, not only the mission that I was a mission manager on in Phoenix, did we dig it up on the surface of Mars, not only is it in comets and asteroids, we're finding it on the poles of the closest planet to the sun, on Mercury. And it's just everywhere. And the great advantage of it is, unlike in space where everything is measured by distance, where you usually think Moon, Mars, asteroids are all very far away. If you think about space in terms of the energy that it takes to move around, and I'm trying to animate to the next part of the presentation here. There we go. In space, really, everything in space is relatively close to each other when you consider it an energy standpoint. The moon is relatively close to the asteroids are relatively close to Mars, and it's the Earth that is very far away. And we have been exploring space for 50 years, putting those 537 people up into space. 541, close, 5 short, 4 short. We have been doing it with technology that, save for the space shuttles, we have thrown away with every trip, and that's why the cost is so expensive. So to put it in perspective, here is one of the most recent small asteroids we've explored. This is the smallest object in the solar system that we have explored in detail. You can see Seattle's Space Needle at 184 meters there to the left of it. And this is the asteroid Itokawa. The Japanese sent a mission to this in 2006 and have actually returned very tiny amounts of sample from it. And this is something that is a fascinating illustration of physics. You can see on this one object both rocky pieces that are sticking out on the edges. You can see fine seas of fine-grained material that have been grain size sorted down to the lowest gravitational point. And if you're an asteroid miner looking at this, you think, well, if I've got technology that I can deal with big rocks, I can see big rocks all over the surface of this. If I've got a crushed material and I don't want to deal with the energy of crushing and sorting material, well, nature has taken care of that for me already, and I can just go to the parts there and scoop up the materials that have already been processed. And we've been able to connect those samples in space with what we see here on Earth and know that this is an LL4 chondrite and can tell you in detail exactly what that means because of all the meteorites that have landed back here on Earth. So our job is actually to create technology that allows us to do that more and more and really find the best real estate on the solar system to start this out. When Columbus started exploring the New World, he was looking for a trade route to India, and he happened to run into the Americas. But he was looking for the shortest way to get there. He didn't want to go over land because the land took a while, so he wanted to go by sea. So in a lot of ways, we're looking for the shortest, most efficient way to go out in space and get our foothold so that we can exploit these resources and set up infrastructure that allows us to stay in space indefinitely. And we're doing that through the creation of the ARCID spacecraft and the ARCID series of prospecting spacecraft. And as Doug mentioned, the very first one that we're putting up in orbit here in a few years after our technology demonstrators next year, we found an opportunity to match the interest of everyone in the public with what we were doing. And we did a Kickstarter campaign that we actually closed right here in the area that you were sitting. I beat Bill Nye the Science Guy at a trivia contest. I'm very proud of that. But we've brought 18,000 people along with us for the trip. And this is participatory exploration and something we can do because our spacecraft don't cost billions of dollars. And they aren't something that we wait decades to do. We'll be launching many, many spacecraft, and the opportunity for us to not only engage people and directly satisfy their interest and allow them to kind of touch the solar system, in some ways will actually even be allow those people to help us get there through analyzing better ways to look at asteroid data, to be able to discover things, and maybe find technological solutions that even the professionals might not have a guess at. So that's the short story on planetary resources and how we're pursuing things. We are always looking for the best and brightest and have a number of positions open that we're hiring for. It's right here in beautiful, sunny Seattle, right up here till last week. Enjoy the conversations that we're going to have here this evening.
Thank you, Chris. I really want you to note that number that he said. The Kickstarter campaign raised $1.5 million, which was extremely impressive. But maybe more importantly, over 18,000 people from around the world said, essentially, I want to go. I want to be part of this. I think that's the tip of the iceberg that we've seen every time that the subject gets out there in a realistic way to people. Bob Brown, who ran education at NASA for years, a good friend of mine, used to always say there are always two things that can interest kids in science: space and dinosaurs. If we ever get dinosaurs in space, we've really got it made. Well, Chris has kind of done that with asteroids, and will with the idea that people really are going to take a ride soon. Now, how do you turn those into businesses? Well, these two already have, but there are a lot of other people with ideas out there. And our next speaker is an expert in that end of things. Joe Landon is the managing director of the Space Angels Network that's helping invest in companies in this very exciting field. Joe?
Thanks, Doug. Thanks to the MIT Enterprise Forum folks for putting this on tonight, and for everybody for coming here and joining us. I'm very excited to join my two friends here, Chris and Will. So unlike these guys, I don't represent a specific company. As Doug mentioned, I'm with Space Angels Network, and what we are is a global network of angel investors focused on this field specifically, so space, aerospace companies and startups. So I think it's important to set the stage to describe, what is angel investing? I mean, what do we do? I mean, angel investors are individuals, and they invest their own money in startup companies. And it's often the first outside capital into any new startup company. It usually comes after the 3 Fs, which is the friends, family, and fools who invest in startups. Next is angel investors. So it's actually one of the largest sources of capital for private companies in the economy. There were 67,000 angel investor deals completed last year in 2012, which represents over $45 billion in capital going into startup companies. Now, this is across the entire economy, all industries. But that represents over 250,000 active investors who are just individuals, wealthy individuals, who put their own money into companies. So the purpose of Space Angels Network is to corral those investors that are interested and passionate about space and aviation and aerospace and give them a way to discover opportunities to invest. So we're a matchmaker. The angel investor community is typically arranged by geography. So there are folks in Seattle and California and Boston and all over certain cities that have an angel group. But the problem with that is there's not enough individual investors interested and knowledgeable about space, and there aren't enough companies pursuing space ventures in any one city to have a thriving community of investors and companies in order to get together. So that's where Space Angels Network comes in. We are a global virtual network that connects investors and startups in the space world together. So the way we got started was to pull some of the greatest, the most active investors out there, and these are our founding members: Esther Dyson, Stephen Fleming, David Rose, and Ed Tuck. And these are folks that were investing in space companies already. And we went to them and said, what is the biggest problem you see? And then they had problem finding companies to invest in space, and also other investors to invest alongside of them. So again, that's the problem we solve. We connect these folks up with each other and connect the investors with the companies. We've got a great team of folks supporting our network. In addition to several dozen investors who are part of our network, we have a team of folks, two of which are here, Amaresh Kolapara and Harrison Stenke here tonight, who help support the investors and find companies and invest in deals. We've invested several $1 million in many different companies, not all of which are publicly announced. A lot of times in the finance world, publicity isn't always something that folks want to talk about, these deals publicly. But we've been very fortunate for our investor members to have founded or funded many of the top companies in the world here. So I think that's pretty much it. My background, I'm a recovering aerospace engineer. I used to work for Boeing in their space business in California until I actually was out in Mojave for the first 2 of the 3 flights that Will mentioned earlier. And it was just a few months later I quit to go to business school, where I've since been working with folks in the industry and working to bring people together and bring private capital, new investors, new money to support the early stage companies in this industry and to make them successful.
Thank you, Joe. All right, so you can see we have 3 very different perspectives on this topic. I'm going to get into some of the questions first that were mentioned in the brochure that was, or the information that was sent out ahead of time, and then some others that have come up since, and then eventually the ones that you'd like to have the panel address. But let's start from this idea of the developing commercial space economy. Not just a company, but an economy. So, I don't know, let's start here at the end with Will. You say you guys are going to fly next year. We know other people are doing similar things. How do you see this commercial transportation industry evolving? And you each have a microphone behind you there. We'll just make this a discussion.
I think it's an extremely exciting time because, wonderful things have happened in space in previous generations, certainly, but space has always kind of been both a monopoly and a monopsony. There was one provider, NASA, or its equivalent in other countries, and one customer, NASA. That has changed a little bit in recent years, and certainly you have important companies like Boeing and many others that have contributed to that, but really they were all sort of feeding into the same ecosystem. Now all of a sudden we have an area where there are multiple different providers, each with a different business plan, taking on a different type of project on a different time scale at a different price point, serving a different customer. So one thing that I really like at Virgin Galactic that is fairly rare in the aerospace business is that our customers outnumber our employees. And that's not usually the case. For most aerospace companies, really their customers are about 530 or so people who live on Capitol Hill.
Our customers, well, we've already got 620 or so, as I mentioned, that are waiting in line to fly on Spaceship Two. I didn't have time to get into, but we have a small satellite launch vehicle program called Launcher One, and we have a number of companies, including Planetary Resources, who we're in talks with now about using that. So this gets exciting to me because it means that space is no longer beholden to the success of a single provider, but it's also no longer beholden to the appetites of a single customer. If Congress were to be in a place maybe where it seems to change its mind every month or two, hard as that is to imagine, we no longer have to worry that that's going to shut down progress in the industry.
Chris, you're looking out a little farther. How do we get all the way to mining asteroids?
Well, I've got kind of two things at the top of my head in both looking far forward and also looking far back. In a lot of ways, what we have been experiencing in space is at the back end of a miracle that was performed in the 60s, where this nation literally pulled out of the future an act into a time where it never ought rightly to have been. And it was an absolute miracle. And we've been trying to figure out how to kind of replicate and perpetuate that miracle ever since. But if you go back to the Wright brothers flying at Kitty Hawk, that grew more organically, as did Silicon Valley grew more organically. And I think what we're doing today is in part returning to a time when space exploration and the businesses associated with pursuing opportunities in space exploration are growing more organically. There are opportunities in markets that involve experiences. There, of course, have been great markets in data. And we're starting to have the first steps of companies like ours going out in the solar system, competitors in the Google Lunar X Prize, something that Will used to spend a lot of his time thinking about when he worked for the X Prize. And our job really is to go from a failure is not an option attitude that developed in the government exploration program of failure is the only way to get there. And that it's likely that 9 out of 10 companies or individuals or groups that are trying this won't meet their goals. In the process, some of them will, and in the process, others might find better goals to reach rather than the ones they started originally pursuing. And this is a much more natural progression of pursuing the business. So I think we're at a great time in history where it is something that more people can try, and it is going to be very interesting to see them do that.
Yeah, so building off what Chris said, I agree. I think part of the problem, or why space development and commercialization has gone slowly or has appeared to, is because there's a really hard problem to solve first, which is getting to space. And I think just because technology had advanced to a point where that problem is starting to go away. And we've got folks like Will and Virgin Galactic with their Launcher One, and Elon Musk and with SpaceX, who have kind of laid the framework. So they put in place the railroad, and now it's time for the entrepreneurs to use that infrastructure to build businesses around it. It's not necessarily a rocket business, which gets a lot of attention in the space industry. But what we see in Space Angels Network are not rocket companies nowadays. We're looking at companies who are leveraging that infrastructure that's in place to build service businesses and product businesses around that infrastructure that is now there.
Joe, talk a little bit about Andrews Space, just down the street here, doing exactly what you're talking about there, basically integrating other people's capabilities for people who want to do research or education or whatever.
Exactly. I mean, there's an opportunity there where this is a service provider who can put together, provide a service to get payloads into space. I mean, there's a great business there, and our members at Space Angels Network invested in NanoRacks, which is a complementary and a partner there, where again, that's a company, NanoRacks, over close to $3 million of private capital was invested recently with the angel part of that money led by one of our founding members to build a service business that's making money today and really enabling some of the work that these other companies are doing.
Yeah, Planetary Resources, actually, our first technology launch next year is through Jason Andrews Spaceflight Services, and NanoRacks is helping do that for launching spacecraft from the International Space Station.
So I don't want to beat this to death, but it really struck me recently that this is sort of the equivalent of people now You know, I used the personal computer analogy before. If you were going to be in that business, you had to go build a computer. Then some company named Microsoft came along and said, well, we'll do the software. Then people started integrating systems and so on. Now I don't have to think about any of that. I can just write an app. So we're not quite there yet, but we're getting to the point. I don't have to build a rocket. I don't have to build the infrastructure. I can think of an app that I want to do in space. And there will be people who will have the infrastructure, at least within the next few years. Virgin Galactic, you mentioned you're actually manager of special projects, and I know most people think of you as carrying passengers, but what else, what kinds of apps or capabilities are you looking at beyond that?
A number of them, yeah. Definitely space tourism is kind of the brand identity. If you've heard of Virgin Galactic before, that's probably the context in which you've heard of us. But that's not the extent of the business. Sort of the vehicles that we built to carry tourists can function equally well to carry teachers or professional researchers, educators, scientists of all kinds. So we've actually worked with NanoRacks, the company Joe just mentioned. They built a rack system for us where on any given day we can pull some of the 6 passenger seats out of the back of the vehicle, put in a NanoRacks built system that'll allow you or your child's middle school class to fly a payload into space. And you can do that very quickly. You can do that very affordably. To me, that's fundamentally exciting. My academic background is actually in earth and planetary science, and I don't do science anymore. The main reason why is because I got incredibly frustrated as a planetary scientist with the fact that if I was really, really lucky, I might get to collect new data once a decade, if everything worked out well. And that wasn't the pace that I was necessarily looking for. We're now entering an era where not only can a first-year master's student be collecting data on his or her experiment by the end of their first year, which I think is fascinating, but your middle schooler could do it. We're pretty close to the point where your middle school bake sale could fund a CubeSat that you could send to space. And that's going to do 2 things. One is it's going to get a lot more students to enter science, technology, engineering, and math careers and stay there, which is just as important as getting them in the door. And 2 is when you can try things that quickly and that inexpensively, you try much crazier, more ambitious things. You do the Hail Mary passes rather than the 1% incremental improvements, the 5% incremental improvements. We need to get access down much cheaper, and that's something that we're doing at Galactic and Planetary Resources doing. A lot of companies are doing it this day.
Yeah, Chris, talk a little bit about that. You mentioned bringing costs way down and getting away from the failure is not an option attitude. Talk about how you're approaching that. How are those costs coming down? What are your orders of magnitude, and how do you do that?
Well, I think the thing that it is most enabled by, as Will had mentioned earlier, is the number of people that are on the payroll. Rather than having something that is done by thousands of engineers using a facility that spans acres of campus, this is something that 30 men and women and high school students and college students can undertake. And because of that, we can kind of do things more quickly because we're trying to do simpler things. We're trying to do them more often, and we can experiment as we go. So rather than, as Will mentioned, being able to do something once a decade, that breaks my heart to think of the thought of that, but that's the environment under which we do science in space today. And I often get asked the question, well, why is space so expensive? And I have kind of a circular answer to that, is because it is so expensive. You spend a lot of money on it, so when you invest that much money on it, you want to spend more money making sure that it'll work okay. And when you spend more money on it, now you take more time in doing that, and it just takes you a long time to do something, and you end up with 20-year-old technology roving the surface of Mars, and this is where we are today. The innovation that we have seen in the information technology, the consumer microelectronic, the medical, and even the automotive sectors has, at least a decade ago, far surpassed most areas in what we consider high tech in space exploration. Because we've been trying to come out with the next tablet or the next cell phone, or make broadband go faster to your house, or get embedded electronics into every device in your life. And all these things that have been iterating, not because they're waiting for the next planetary launch window, but they're waiting for the next buying season. These are opportunities that space really has yet to leverage into bringing down the cost of space. So those are a lot of the ways that we're looking at taking commodity capabilities and taking risks on them and probably failing a few times along the way, but finding those tricks that do work that allow us to get the cost down.
Joe, are there investment opportunities in that bringing down the cost sector, or are you guys mostly looking at app-type uses?
Well, I think the app analogy brings up an interesting problem. I think there's the problem is that venture capitalists and even angel investors are used to investing in apps and very quick return businesses. So about 50% of that those angel investor deals that I mentioned were internet and app-based companies. So there's a disconnect there between getting mainstream investors to then pay attention to a hardware company. I mean, it's a little bit different of a risk profile to invest in a company building spacecraft or mining asteroids versus someone who's going to build an iPhone app. Even though I think it's two worlds that are converging. So the space world is getting less bureaucratic, less long, less capital intensive, but the investor community needs to change also. It needs to, and it is, it needs to start thinking a little bit more long term and paying attention to some more of these hardware investments, which is where the venture capital community started out with computers and semiconductors. And we see that happening. But I think that that's a challenge for investors, being able to look at these companies. It's a little bit different than the normal company out there.
Let me ask you another one, Joe, sort of business-oriented. We talk about commercial space as if it's a new thing, and we tend to ignore the one part of commercial space that's been incredibly successful that we all use every day, communications. I mean, there's not burgeoning, a huge existing infrastructure of satellite communications that's involved in every transaction that we do, from the gas pump to our credit card instantly, and we just sort of assume that now. And parenthetically, I just saw that DHL plane take off out there. I can order something on Amazon today and have it at my house tomorrow using space technology and aviation technology every step of the way. Are people trying to branch out from that existing space industry towards any of these new applications?
Yeah, I think so. I mean, you're correct to point out the commercial space, commercial satellite industry and communication satellite is huge. It's a multi-billion-dollar industry, and it's been around for a long time. But it also suffers from the problem that Chris mentioned, which is because launch is so expensive and building a spacecraft is so expensive, when Boeing or Lockheed or L'Oreal build a commercial satellite for DirecTV or someone like that, it's very expensive and it's designed to last a very long time. So what we're starting to see now are opportunities of companies coming in and disrupting that industry. A really interesting one that we've seen a lot of activity in is the Earth imaging industry, where it's been dominated by two big players, which now are consequently one big player. It's very expensive. It's focused mostly on the government as a customer. But we see now many companies coming in and providing a lower quality product, but at a dramatically, orders of magnitude lower price point. So Skybox Imaging is a great example. They've raised tens of millions of dollars from venture capitalists in Silicon Valley to build a low-cost Earth imaging company and service company to go after this existing infrastructure, the existing players, commercial players in that industry.
So, launch costs. Will, you referred to this. How are we going to bring them down? We've got the Karen test vehicle from Blue Origin sitting over here that flew in Moses Lake a few years ago, trying to learn to basically land a rocket back on the pad. Who's going to do that?
I think it's going to be a number of different companies approaching it in different ways, because we need to both bring down the relative price and the absolute price. If you look at the cost of space launch from Sputnik to today, the cost of putting a pound or a kilogram of something in space is essentially exactly the same as it was in 1957. It's actually gone up a little bit. We haven't been on a Moore's Law curve like they have in almost every other high-tech industry. So we need to tackle that problem. And I think companies like Elon Musk, SpaceX, are probably getting us down as far as we're going to get on this generation of technology. Hopefully there are the bright entrepreneurs out there in school now or meeting with Space Angels Network to get started up with the great ideas for how we get off that chart. But we also need to bring the absolute price down. Your typical rocket, if you want to put something in space right now, well, your typical rocket is giant, and it costs a giant amount. You can buy something from SpaceX for what? I don't know what a Falcon 9 goes for now. $50+ million. Even if it's really cheap per pound, that's still $50 million you got to raise from an investor who could otherwise be investing in Instagram or something like that. When they can buy in bite-sized chunks, that allows us to get the foot in the door, get the first spacecraft working, prove the business model, prove the technology, and then get to the point where you can afford to buy that $50 million launch, because now you're funding it off revenue instead of funding it off a speculative investment.
Yeah, and that's something that I'd like to add, that, you know, it's like, well, you can get milk very cheap if you buy the whole tanker truck. And that's been the challenge in exploring space. And I'm so happy that companies like Virgin Galactic are matching the demand with the supply, so that if you only need a little bit, you can buy a little bit. And it's a good example of a lot of different developments that are all inching forward across the spectrum to allow new businesses like these to be able to make that forward progress.
I wonder if I could just jump back in for a second. So if you look above you here, you see a model of the Hubble. Now that's what, half scale? So that's half scale. So now Hubble's a huge satellite, but satellites traditionally have been very, very large, and the rockets have matched them. Chris, I wonder if you would indulge me. Could you just give us the size of a telescope that will be used to find asteroids and eventually to go and visit them?
Yeah, so our ARCID 100 space telescope that we're making, which is inspired and has many of the same capabilities that the Hubble has. It can take the same spectrum. It has many more pixels. It has a way better computer, and it's something that you could fit one Hubble in the back of this shuttle payload bay. We could fit a few thousand of the ARCID in the back of the payload bay, and each have their advantages. But I'll take the few thousand. There we go.
So there's a very interesting competition in the same vein that's been going on now at Kennedy Space Center. I'm sure most of you know there were 2 launch pads there that have been used ever since Apollo to launch all the manned missions. And NASA intended to keep one for itself, for the Space Launch System and other projects that it's working on, but to lease out the other one. And everybody assumed that would be to SpaceX, until Blue Origin stepped up and said, wait, we want to use it too. It's sort of interesting to see 2 great entrepreneurial companies competing for the scarce resource of a launch facility. They both, of course, have their own already that they've built, but the bigger rockets that they'll need to do the longer missions need a space like that, and they're saying to the government, wait, let's at least bid on it. It's a pretty neat competition. Interestingly, done by people like Elon Musk, Jeff Bezos, mentioned Paul Allen, Richard Branson, certainly the Google guys, Ross Perot Jr. Chris, a lot of these folks are your investors too. What's it like working with these entrepreneurs that made their money doing something else visionary and are now in the space business? Are they just hobbyists, or they really think they're going to make money at it?
Oh, they really think they're going to make money at it, and they have a mindset. I mean, Elon Musk has been admired the world around for not only his visionary ability to create a rocket company in the way that no one ever has, but he's also created a really good car company. And if that's not enough, he's working on solar energy as well. It's a type of thing that Elon started his company in 2002, and around the same time that NASA was working on developing the next generation of capability that was going to replace the shuttle. And in the space of about 6 years, NASA had refurbished a pad and designed a new capability for that, and then launched a rocket called the Ares 1X. And they spent about $400 or $500 million over the course of several years in doing that. In the same amount of time, with the same amount of money, starting from nothing, Elon built up SpaceX and designed the Falcon 1 launch vehicle, which was built from scratch, which they didn't buy the rocket engines, they built them from scratch, brand new technology. And then he designed the Falcon 9 launch vehicle and built a new facility for launching that. And then he also designed the Dragon capsule that went on it and did the first successful launch. And he did that with about the same amount of money that the government did to do one thing. He did 4 times from scratch. So it's just, he did it at much greater risk. But it's something that when you have an opportunity to kind of step outside of the constraints of bureaucracy and take some risk, and they came very close to completely failing, and they may still yet. But there are plenty of people who are waiting on their heels to serve that market.
Yeah, that's the other side of my analogy about the a personal computer business. Most people forget there were more than 50 personal computer companies in about 1980, and only 1 or 2 survived. So it's an interesting time, and it's so wonderful we have people willing to take risks. Joe, a lot of those people are here in Seattle. We've mentioned Andrew Space, of course, Planetary Resources, Blue Origin, Paul Allen's new project, Straddle Launch, where he expects to send about 10 times as much money on a much bigger spacecraft than Spaceship One to go all the way to orbit. Aerojet, that's made rockets for every American spacecraft that's ever launched, right over in Redmond. And of course, most people don't realize Boeing is in the heart of this commercial space business, building their CST-100. Is this the Silicon Valley of space?
Well, I'm not sure we want to apply the Silicon Valley. I think we'll be something better than that. I mean, I think maybe it'll be Silicon Valley will be the Seattle of internet, maybe someday. Yeah, I think it is. I moved here about a year ago because I saw the momentum building, and there's companies here, and there's people picking up and moving to Seattle. It is a great place to be. We've seen a lot of interest in investors in the area. It's a very affluent community, so there's angel investors here looking for places to put money, and that's a great reason for entrepreneurs to be here looking to start companies. And the more companies that move here, the more and get started here, the more that gets reinforced. So we're starting to see a space cluster here, to use that terminology. And I think that's only going to continue.
So we talked about a lot of the upsides and the possibilities. What are the risks? What about the government? What about a crash? What about ITAR and some of those kinds of things? What do you guys worry about that would stop this forward momentum?
Well, I'll start with ITAR. I mean, it's already stopping the momentum. I mean, the commercial satellite
Explain ITAR just a little bit.
Right. So ITAR stands for the International Traffic in Arms Regulation. It's basically export control rules that the U.S. government, starting all the way back in the Cold War times, to prevent our rivals in the world from getting our technology. And somewhere around, I believe it was 1999, the Department of Defense took over export controls for space technology. So everything, just about everything that is related to space in any way is considered a weapon and is on what's known as the munitions list.
If I take this, disassemble it, and then make it into a spacecraft, I have just created something that is regulated the same way that a weapon is.
Like an F-16 or a Sidewinder missile. I mean, it's the same exact regime. So that, I mean, it's not exactly able to be known the exact impact of that, but estimates have ranged from about 50 to 80% of the market share of the commercial satellite industry that the U.S. had has been lost during that time. So what has happened is the U.S. government has restricted the export of technology so that a company like Chris or Will, even if they have an investor or a customer who happens to not be a U.S. citizen, they can't talk to them about the technology. And they're actually very strict penalties if they do, both personal and company. You can go to jail if you talk to a foreign national about satellite technology. So that is a big problem right now in the industry that needs to be addressed, and there is some movement on that.
So, Will, you couldn't launch Spaceship Two from outside the United States, is that right?
Not yet. We're certainly working to get to that point, and I'm pretty confident that we will, but it's a new vehicle. It takes a while to get a regulator comfortable with it, especially when in the aerospace community, because of the way ITAR and other regulations have been enforced, there's sort of a presumption that the answer is no until you force them to say yes. So we have to do our due diligence and make sure that we're keeping up with the spirit and the letter of the law, and we'll get there eventually. But yeah, for now we are restricted to U.S. spaceports.
And one of the questions people often ask is, well, what about point-to-point suborbital flights? What about Los Angeles to Paris in 45 minutes? And obviously, you couldn't do that now because of government regulation, let alone the technology.
We really want to get there. Sir Richard has made no bones of the fact that he would love to get to a vehicle. You know, he's a guy who spends a lot of his life on airplanes. And if there was an LA to London flight in 45 minutes, he'd be one of the happiest people out there, especially if it was his company's name on the side of the vehicle. That's a ways away in terms of technology. You know, Spaceship Two can't do that. That's probably Spaceship 5 or something like that. But we're learning the technologies now. Actually, that's a part of the reason why we're doing things like Launcher One. It allows us to get smarter about those key technologies. But us being the smartest people in terms of technology means nothing if there's not the regulatory regime, and we got to get there.
What about a crash? I'm sure you guys have thought about what happens. I mean, a lot of airplanes went down in the early days, and they still do once in a while.
Yeah. It's humbling to think that we need to, as a business, be many orders of magnitude safer than this thing was. This is an awfully impressive vehicle. If we have that safety record, that's not going to be very good for us. We got to be much, much safer than this. It helps that every employee at the company desperately wants to fly and desperately wants our loved ones to fly. It helps that our first commercial customer is our boss, Sir Richard, and his family. We are not cutting any corners when it comes to safety. We've got to design a vehicle that is as safe as it can be, and if there's ever a day, heaven forbid, where things aren't going right, that it fails in a safe way, that we can come back home and say, hey, maybe we didn't meet the mission we meant to meet today, but the people have come home safely, and that's why we chose the team at Scale Composites. We watched the X Prize effort very closely, and we loved a lot of the key design features in Spaceship One that have been carried over into Spaceship Two, because we think it's what's going to make sure that we hit our safety goals.
Yeah, I think that one point actually is worth emphasizing, that about making things fail in an acceptable way. And in some ways, that is one of the reasons why we, as a space agency, retired the shuttle. Because when they were evaluating the safety record of it and how to make something as complex as the shuttle safe, you can look on the other side where people had to egress out. That was a capability we never really used. And going back to the good old design of a capsule from 50 years ago, it turns out from a system level is much safer. So I think across the board, it's just kind of recognizing that bad things happen. There are things that you can do to plan for that being okay, and not spend all of your attention trying to make it never happen, because you can't possibly prevent it. But designing it into the system so that you can deal with it when it does.
I heard a great analogy. I'm sorry, go ahead, Joe.
Investors think about the same way. I mean, if I'm investing in a company, I want a company who's going to fail fast, fail often, and learn from it, and not spend all my money and years figuring out how to make it perfect, and then find out later that's going to fail anyway. So I think that really is well aligned with what investors are thinking today, is to reduce that risk, but do it very incrementally.
I heard a great analogy the other day from one of our docents about the early days of aviation, when the life expectancy of an airmail pilot was not very high. The government's involvement in scheduled air routes really wasn't for passengers, it was for the mail. The Boeing 40 that's over in our gallery across the way there, the Boeing sold 30 to the post office. In fact, I should point out that was the only 2 years in history the post office made money, was when they flew the airmail in the early 1920s. And carrying passengers was a secondary thought. The fact that I could be in California tomorrow from New York, it took 11 stops in 36 hours, but I could be there tomorrow, was Mr. Boeing's innovation that eventually got people thinking maybe passengers could even be bumped by the mail, by the way, if there was too much mail. But the point is, people saw the opportunity and got through the fact that the planes weren't very safe. There's something different in society today that sort of demands perfection. And I don't know, do you guys worry about that? Do you talk about how you'll handle it if there's an accident?
Yes, certainly.
Or if I'm beating that subject to death, you can tell me.
Certainly it's something we think about a lot, and I think it's an advantage that Virgin Galactic has, is that we're not the only company with Virgin in the front of our name. We have sister companies who run airlines, who run train lines, have a wonderful safety record, and have a great history of planning to make sure that the really bad days don't happen. We know our customers are very interested in this. Like I said, we all want to fly, and we may go skydiving for funds and things like that. Some of us, but not all of us. We have a perception of the safety of the vehicle, so we need to make sure that we're doing our job and we're telling the story about how we're doing our job.
Any other subjects you three would like to address before we open this up to the audience?
Let's open it up.
I know, let's open
Anything
it
we
up.
haven't thought of? Great. Well, we have a couple of people who have volunteered to take microphones around, I believe. And Yes, right back there. And so I'm sure you all have thoughts, comments, and questions for the panel. Let's just ask for a show of hands and start right here in the middle.
We've been using the...
Here, can you make sure those are on?
Can you hear me now?
Yeah, there you go. Just put it up close.
Okay. Well, we've been using the computer industry as kind of a model for thinking about this. And you've pointed out that in space, we don't have the advantage of a Moore's law. So it does seem that we have certain quantum leaps that are possible. So the one that's happening right now is that we're going to reusable spacecraft. Okay, and that's bringing the cost down a lot. And so I think that's one quantum leap. The only one that I can think of that would be a big quantum leap would be a space elevator. That would bring the access to space at a much lower cost. Now, my question to you is, are there other quantum leaps in between what seems like a really huge leap to a space elevator? And if there aren't, how soon can we get the technology for a space elevator? Anybody can answer.
I'll start. Was something I wanted to comment earlier on. Other technologies that really can help change the way that we undertake this activity, from turning activities in space more into an information science rather than just beaming raw data around. I don't need gigabits per second bandwidth if I can figure out how to have someone smart at the other end who can just tell me what the answer is. So don't send a terabyte of raw data, send me the 100 kilobytes that represents the reduced part. So that's an information technology problem. On a different measurement of thing, looking at launch, apologies. On a different metric with launch as an opportunity, talking about space elevator, there are information technologies which actually might change the way that we do launch. Rather than carrying all of the energy that it takes to accelerate something from the surface of the Earth to the many thousands of miles an hour to be in orbit or to leave the Earth, there are people who are exploring taking the mass that you need to accelerate to get that action and reaction force, but beaming in the energy over lasers or over microwaves. Actually, one local company, Laser Motive, has been exploring that technology. So this is something where you can get over the propulsion problem by getting past the energy in the chemical bond. So that's an example where space elevators were something that we could think of a linear approach to a technology that, well, if we just build something big enough, we can get all the way into orbit. There are totally adjacent possibilities that just approach the problem in an entirely different way.
The other one that comes to mind for me is what Chris is doing. He talked a little bit about this idea as sort of counterintuitive as it may be, that in terms of energy, the job of getting from the Earth's surface to orbit is just as hard as it is to get from Earth's orbit to almost anywhere else. I mean, that's a common expression in the business.
You get into low Earth orbit, and you're halfway to anywhere in the solar system.
Exactly. So if instead of having to carry everything up through the thickness of our atmosphere and against this big gravity well up to where we use it in space, if it were already there, if we've harvested it from an asteroid, say, for example, and you can combine that with ideas like fuel depots or additive manufacturing, 3D printing, I think that's a phase change kind of a moment that isn't 100 years out, like maybe a space elevator is. It's a lot closer than that.
There's an analogy there that I've heard increasingly used to the settling of North America. People didn't come here expecting to go back to England or wherever they came from, and they didn't bring everything that they would need. The early settlers expected a supply ship every couple of years, and if it didn't come, they were in a lot of trouble. But pretty soon, they learned to live off the land. And several projects have discussed a one-way trip to Mars and gotten thousands of volunteers. It's pretty interesting to think about, would you go to be one of the first Mars settlers if you didn't expect to come back? And how much easier it is, of course, to go learn to live off the land, either at the top of the gravity well or on another planet. What else? Other questions?
Okay.
Right over here.
Hi, Jim Drexler. I appreciate your discussion here, and I think, Doug, you touched on the peripheral companies or companies that will spring up around these other companies. I'd like to hear from each of you what you see as the possibility for partners or suppliers or other companies around the SpaceXs of the world, because SpaceX is kind of famous for doing it all by themselves. So what do you see for the future?
I don't know if you could all hear. The question was, what other opportunities are there for companies around those that are springing up as the core commercial companies like SpaceX and Boeing and Blue Origin? What other opportunities are out there? Joe, maybe we ought to start with you on that.
So I think there are opportunities. Just like any industry, there are going to be a supply base and a supply chain. But when you look at new industries in general, you see a lot of vertical integration. And what I mean by that is, like you mentioned with SpaceX, SpaceX likes to do everything themselves, but it's not because they think that's cool or because they like it that way. Well, they might. It's because that's the only option they have. If you're building a rocket company, when Elon started doing that, and you wanted to had a specific goal in mind for a cost target, you couldn't go and buy a rocket from Rocketdyne, or you couldn't buy a space batteries from whoever, because all those technologies were built within a totally different paradigm of cost and performance, and that was tailored to the government customer that we were talking to earlier. So I think we're going to see very early on, and I think you'll hear from Chris how they're following a similar strategy, is by necessity, these companies are doing it all in-house because no one does it the way they need it to be done. But we're going to see that change, and over time, people are going to see that an opportunity there, and Elon or SpaceX is going to be able to look out and have suppliers. They're just not able. They don't exist right now. So there will be opportunities for that in the future, though.
Yeah, I think it'll, not only, like Joe mentioned, in terms of suppliers not being able to actually do the things that the more risky companies might be able to do, is if we were to ask some suppliers to cut some of the corners that we don't think are necessary in the type of business that we're pursuing, they might lose their certifications that they have that say that they follow this internationally recognized process. So that's something where it kind of limits them because the current ecosystem of businesses support that. I think also what we'll see is that space will become much less of something that is special. And this is something that I actually love to see happen. I like going to space conferences and having people who have been going to the conferences for 15, 20, 25 years complain that astronauts aren't heroes anymore, and no one knows their names, and no one who knows who was on the space station, and I actually think that's progress. It's happening so often that you can't possibly keep track of it all, and it's becoming routine. Routine is awesome. Routine is reliability and cost efficientness, and it's not a press event every time that there's a launch, just because, another DHL aircraft took off today. Well, what is that, the 17th today? And it doesn't matter. Who cares? So I think we will see a lot of different industries have as part of their portfolio this serving of businesses that just happen to be doing things that leave the planet.
Chris, we had our big annual gala here last year honoring some of the Apollo era astronauts. We had about 35 astronauts here. And it was really interesting about halfway through dinner when it struck me that Buzz Aldrin was here, Jim Lovell, all these kinds of people. The only one in the room likely to go again was Brian Binney, the test pilot for Virgin Galactic. And so I leaned across the table. I said, Brian, when you guys get operational, how often will you go to space? And he said, about once a week. So that's a whack on the side of the head. This is the man who was flying that plane, that spacecraft that you saw in the video. He'll go about once a week. We don't know the name of the person that flew us across country today, and that's a good thing. Next question. Have over here. Thank you.
Hi. I was wondering, in a lot of investment, there's sort of network effects or first mover advantage. This seems like, I was thinking about the explorers at Roanoke Colony. There was sort of no first mover advantage there. Where, in terms of first mover advantage, how do we understand that concept when it comes to your guys' businesses?
I'll start. Often it's said that the pioneers are the ones with arrows in their back. And I learned from starting from an engineering environment where you were thinking, oh, this is great. We're a first mover in this area. And one of the earliest questions that we got when speaking with investors is, who are your competitors? And in this case, not having competition is a bad thing, because they like to see that there's enough business interest in this activity that there is a form of competition, either directly or indirectly. But we actually do have, even in asteroid mining, multiple companies who are pursuing this now, who are courting investors and developing technology and engaging with NASA. We have multiple companies that are trying to land on the moon. We have multiple companies that are exploring new businesses in Earth orbit, dealing with servicing spacecraft and managing orbital debris. So first mover has its advantages, but it also has its disadvantages. So it's really what we see is all of the activity is good. A rising tide lifts all boats. And we're establishing really a new form of industry, and we need as many players as possible in doing that.
Yeah, from an investor standpoint, I think there's also the idea of getting in first and being one of the first investors in a new area. And our investors, they look at a couple different definitions of value. So, of course, the very first thing that they're expecting is a good return on their investment. But they also want to, hang out with their buddies and say, hey, yeah, I'm an investor in SpaceX, or I'm an investor in Planetary Resources. So there's some value there. And just being able to be part of a new industry and in pursuit of good returns. Getting in early does have its advantages. Particularly, like right now, if you wanted to invest in SpaceX, you can't. So at one time you may have been able to, but there was an advantage there, and that company's going to be very successful and likely do an IPO or some other sort of liquidity event for their investors that isn't available to people who didn't act very early on.
And I'll just add, for all the reasons that we've been discussing tonight, space is getting a little less capital intensive, and the time from idea to execution is getting shorter. But it's still pretty capital intensive, and it's still pretty long startup times. So I think there definitely is a first mover advantage. I think people are going to, in every one of these sectors, enjoy a couple of years, probably of relative comfort. But the good news is that space is about the closest thing that my brain, at least, can handle to infinity. So there's a lot of room out there for competitors to come along and for many companies to succeed.
I heard of Dennis Muhlenberg, who's the head of the defense division of Boeing, based in St. Louis, said to me once at a program like this, we're in this commercial space business because a huge customer of ours, NASA, wants us to be in this business. But my CFO tells me we're not that far away. We're not that far away from it being a business we should invest in. So it's great that somebody's encouraging us to be there. When somebody's really ready to build a lot of these, we're going to build them. I thought that was an interesting thing. Yes, back on this side.
Yeah, hi. I'd like to ask this to all of you.
Can you see if that mic can turn on? Is it on the bottom?
Hello?
Okay, there you go.
Oh, there we go. This is especially for Joe. I'm not an engineer, but it seems from my recollection of the space program that NASA did a lot of things that first took a lot of basic engineering research for materials, for fuels, for all kinds of things like that. That took forever, and most of the things they tried to develop were dry holes. And it took an agency like NASA to be able to absorb that tremendous cost with such a long time before there was any payback. But then finally, the fuels and the materials and all that came together and enabled NASA to build these very expensive but amazing systems. With you folks up there, I'm assuming you still need new technologies. You're not just taking existing technology and integrating it. So how do investors deal with this tremendously risky, incredibly expensive, low volume, low success rate process that basic research is?
So I think the answer is by investing in companies that are low capital needs, high volume, and low risk. So in fact, I would argue that these decades of NASA and government dominance of the space industry actually did a disservice to the commercial industry that's forming now. We're looking at companies that, like NanoRacks is a great example, where it's taking advantage of all that basic research that has been done over the past years to build a business out of it today. And that's really how investors think about this. You know, myself and other investors included are looking for companies that are going to be able to make money in 3 to 5 years and pay a decent return in that period of time. And you can't do that doing basic research. Although, I mean, if you also look at other industries, so a lot of angel investor money goes into the biotech and pharmaceutical industry, which, you know, you can argue that that's even harder and more capital intensive than the space industry. But good deals happen, good products come out, and investors make money there too. So it's possible, and I think it's just a matter of picking the right companies and leveraging technology and that basic research to create a great business model that makes money.
The question is, can you do this without government investment?
Well, I'll actually give a specific example to that. And a lot of areas in Planetary Resources case, what we're doing in the early parts of the process are not using brand new technologies. Like you said, we are indeed integrating things that already exist. We're just doing it in a more creative way. And longer term, we will have to undertake very capital intensive things when we get around to the actual act of mining asteroids, but in some ways we have parallels that have been going on for decades on this planet to follow in the example of. Offshore oil wells are an excellent example of a technology that costs billions and billions and billions of dollars to develop a machine that can be out in the middle of the ocean in currents, can go through tens of thousands of feet of open ocean and go through tens of thousands of more of subsurface ocean to finally get to the oil that might be there. And this was something that companies invested in the early 80s, and it was private investment from these companies that did it because they knew after they invested those many billions of dollars that there were going to be many tens of billions of profits. So that's one example of when there is money to be made, there is capital available to solve engineering challenges. Another thing that I want to call to mind is that the rate that technology is advancing is itself advancing. And the ways that engineers solve problems today do not resemble the ways that engineers solved problems 10 years ago. And I would say that in 10 years, we can't anticipate how we're going to be solving problems. A project that we started in relation to our Kickstarter event back in June was a massively outsourced, crowdsourced data solution. We wanted to find a better way to find asteroids as they move through pictures. And this is something that at least dozens of graduate students worldwide have worked on over the past 30 years. Certainly not into the hundreds, and maybe hundreds of thousands of dollars have been spent. And with the cognitive surplus that exists today of people who have 30 minutes to spend on a weekend, or have worked in similar areas of research of finding pattern matches doing cancer research, we can open a challenge up, offer an incentive to solve that challenge, and we can have 800,000 of the world's best and brightest and most motivated help us solve that problem. And there are ways of people participating in that in all different forms of way, from down to the individual to the team for prizes, or just because they like to move the project forward. So the way that we engineer and pursue things is really kind of taking new forms. And for me, that's one of the most exciting things of getting out of the NASA environment and into the entrepreneurial environment and being able to explore new ways to solve problems.
Doug mentioned at the top this difference between conceiving of a Star Trek future and conceiving of the way that we get to a Star Trek future. And the reason I have great hope that we're going to get to a Star Trek future is that we now have this wonderful point in the industry's history where we can optimize the way research is done and who's doing it. There's so much innovation that's happening right now that doesn't require unobtainium, doesn't require new laws of physics. It's innovation in how we operate, it's innovation in our financial models. You know, when a chief asteroid miner is sitting you telling you he's not using any really futuristic technology, that tells me that there's 1,000,001 business plans out there that can be done by pulling things from consumer electronics and from aviation and from other industries. So while we're doing all that and making great progress and inspiring people and making money, we can be making those Hail Mary passes and investing in those longer term projects that are going to pay off not tomorrow or not 5 years, not on the scale that's probably acceptable to an angel investor and certainly not to a VC, but maybe that it's tenable to a wise government that is able to think about what is the next generation going to need.
There's a great article in this week's New York Times by Thomas Friedman on this whole concept of how major research institutions work these days, much as Chris described. It was fascinating, and it's an interesting juxtaposition. How many of you are aware of the NASA Space Launch System project? See, a few people. So Congress has insisted that NASA continue to build the capability to go beyond low Earth orbit, as they probably should, and we are at Huntsville, Alabama, building a rocket bigger than the Saturn V with 2 scheduled launches, one in 2017 with no crew around the moon and back, and once in 2021 with a crew around the moon and back. And most people in this industry think that they'll be there to meet them when they come back for a lot less money, but it will provide the capability to have a launch system that can be interplanetary, and it will probably build a lot of the basic research and so on, but it's still politics, and we're all voters. And so telling our elected officials where we think NASA and other investing agencies should be spending their money is still part of all our jobs. We have time for about 2 more questions. We have one gentleman way over here, and I'm sorry, it's actually this side's turn if we have one on this side. How about right in the middle?
Hi, this question's for Chris. There's a fairly long way between here and revenue from asteroid mining. And it seems to me there are 2 ways to get there. One is very patient investors with very deep pockets, and the other is revenue along the way. Which path are you going, and can you give us a little more insight into how you see that working to get to that audacious goal of yours?
You've already answered the question. It's very much revenue along the way. It's because of the constraints that we're pursuing our very audacious relatively long-term goal that begets a lot of the innovations that we're doing. So we'll have the capability when we are prospecting asteroids to have a small, very capable optical propulsive platform that can communicate using optical communications that is very low cost to launch on Virgin Galactic's Launcher 1 that can solve a lot of problems right near to here on Earth, and maybe some of the technologies will apply to terrestrial businesses. So there are opportunities to leverage that intellectual property along the way. Also, thinking of it not as an aerospace company, but as a mineral or an energy company, there are many ways in which mines are developed in ways that the first person into the mine never is around by the time that you're actually mining the mine, because there's different people in the value chain. So there will be a combination of those 2 things. And as Joe mentioned, early on it'll probably be the vertical integration where we'll be building the picks and shovels and towing that line all the way to the end. But this is really just going to end up in the long term being an extension of the mineral and mining industry here on Earth that just happens to use aerospace tools in serving that business.
And one more over here on the left side. How about the gentleman? Oh, I'm sorry, right here.
Can you hear me? Okay. So, Will, your story about planetary science rang true to me. I got a PhD in it. Perhaps I'm too stubborn, but I enjoy space exploration and things like that. And so I'm just kind of wondering what you guys think of where science can come into this sort of thing. There's NASA is kind of the new graduate. I got my PhD a couple years ago. Sort of new graduates are playing into this system of NASA is where we write proposals to, NASA is where we do all our science. And there's sort of these new players in this sort of industry where we might be able to actually do some exploration scientifically. And it might be interesting to, as a scientist, sort of get on board there. So just wanted to hear your thoughts on where science and maybe academia can sort of play into that.
Great question, thank you, and thanks for sticking with planetary science after I threw in the towel. I have the greatest admiration for the people who stuck it out much longer than I can. I get excited because I think there's about to be an explosion of scientific data. You know, I talked about this phenomenon of, if you're lucky, you get new data once a decade, and I think maybe that is about to change. So much of science is a numbers game. You know, if you ask a scientist how much good is one piece of data, it was one datum, it doesn't do a whole lot of good. There's a reason no one uses the word datum. Right? You need data, you need plural data, you need lots of it. You need time series, you need geographical series. Whatever you're studying, you need lots to learn, lots to connect the dotted lines and make sure that whatever law you're inventing or whatever phenomena you're describing is a real thing and not just a sample bias. And that's hard to do when you have a spacecraft going once a decade. You know, my particular specialty when I was in the field was Mars, was the geology of Mars, and the way that field of academic study has been totally revolutionized by the two MER rovers, and then totally revolutionized again a few years later, and then totally revolutionized again. That's going to keep happening because our scientists are functioning in a very data-poor environment. Our scientists at NASA, at universities, are so dang good at wringing every last drop of value out of these pieces of data. It's amazing to me how deep people are going and doing some really impressive stuff. There's a reason people can leave planetary science and do like Dennis Tito and become billionaires, because they take those same analytical skills to Wall Street. When we start feeding you a heck of a lot more data, your papers are going to get even better than they are now. So the ways we do that are by having the Hail Mary passes, enabling the new technologies, but a lot of it's just by doing bite-sized science, having something that goes, and maybe it isn't a Hubble Space Telescope, maybe it does a reasonable fraction of what a Hubble Space Telescope does, and we're launching hundreds of them. I think that's what makes it exciting to me.
Yeah, I would add, in the field of geology, the commercial companies who have been exploring oil and who have been mining have funded many dozens, if not hundreds of times over the amount of geology done by the U.S. Geological Survey. The biotech startups have done orders of magnitude more work than the National Institutes of Health have done. And it's in the pursuit of these commercial goals where your paycheck is on the line, not just your grant and your company and your investors and you know, the opportunity to create the next industry. There are ways of pursuing that that will be much better than even the best funded government efforts. And you know, like Will, I'm a data junkie, and you know, I can't wait till we're just awash in it. And we never have to try to worry about does 3 points, is that a curve or a line? Because we'll have 10 million other ones.
Here. Joe, any final thoughts?
Chris actually took the words right out of my mouth there on that question, and so the role of government. I think I'm not a fan of relying on the government for much of anything. So I think that profit motivation and investors pursuing returns are the way to do science and to explore space and to do just about everything else. So just in closing, I think there's lots of opportunity for investors. One thing that I'm happy to be able to announce tonight is that our network has put together a small fund where our folks have chipped in. All of our members, or many of our members, have put in money to form a fund to invest in the winners of the Space Frontier Foundation Business Plan Competition, which is coming up next month. So we, in addition to the $135,000 worth of prizes that are out there for entrepreneurs in this business plan competition, our members are actually going to make an investment in one of the finalists. So that's something that I'm very excited about to announce here tonight, and we'll be able to share more about that later on. But yeah, I'm really excited and encouraged by what's going on in the industry, and glad that guys like Chris and Will here are at the helm of companies who are helping to get great returns for our members.
Chris, anything in closing?
Just in closing, you know, having been a government person and now being a commercial entrepreneur, there are aspects of this that absolutely would not be possible without the investments that the nation has made and that you know, the general public has supported. And really what we're seeing is an opportunity to pick that up and carry it forward. And I'd like to continue to see the public investments we make continue to build this infrastructure, lay the groundwork, do the most difficult things which no one else can do, like land sky cranes on Mars and explore the oceans of Europa and send spacecraft to the edge of the solar system into interstellar space. And then along the way, there's the opportunities for the little brothers to the big brother to be able to start to fill those niches in and really integrate them into the fabric of our lives and the fabric of our economy. And very excited to be alive at a time when we can all see it happen and we can even personally participate in it.
Well,
just to build off that, I think there has never been a time in history where it has been anywhere close to as easy to get personally involved in space. There are so many things that each of you sitting in the audience, that each of your spouses and kids can do tonight to contribute to the space exploration field in a very meaningful way. I mean, that's something great that the Kickstarter campaign showed. With literally 60 seconds and $5, you can be contributing to space in a meaningful way. That was not true, really, at any other point in history. And it can be with your dollars. It does not have to be with your dollars. If you would like to contribute your dollars, I'm sure many of us are willing to accept them. But it also can be with your brain power. Chris referenced this earlier. You can go to a million websites. I like one called spacehack.org. All it lists are projects that you can, from the comfort of your home office, of your desk, of your library, contribute to space exploration. There are tons of data sets out there from astronomers who just need people's help classifying different things so that then the professional astronomer can go and do a scrub at a higher level. There are lines of code that need to be written and reviewed. There are pieces of hardware that need to be developed. You're now to the point where you can buy a $100 kit and build something that might fly into space. And no one is going to ask you anymore, what was your GPA? You don't need to have gone to MIT, as great as it is to have gone to MIT. If your degree is in art, if you don't have a degree, it doesn't matter. You can contribute right now, and you can start tonight. So I hope that some of you will.
Well, first, I'd certainly like to thank the MIT Enterprise Forum for bringing this program to the Museum of Flight. I'd like to thank our panelists. These are the people who are on the edges of making it happen. We started by saying tonight that 1,000 years from now, people will write of this era. This is when humans first left the Earth. Ladies and gentlemen, tonight we met 3 people that are making history. Now, who wants to go with them? Thank you all for being here. I'm sure our panelists are willing to meet any of you who didn't get to ask your questions. Thank you all so much for coming.